This is a racing track in TrackMania Nations Forever that was not created by a human. It was generated by an artificial intelligence that learned how to build tracks by looking at existing creations made by the players. During the training process, it has learned complex patterns that allow it to closely imitate the style of tracks built by real humans. But how did we get there, and how does the AI even learn to generate tracks in the first place? The TrackMania franchise has been around since 2003, and one of its biggest advantages has always been the ability to create and share new tracks with others, with the built-in track editor. We will primarily focus on the editor from TrackMania Nations Forever, which is a free version of one of the older installments, released in 2008. The editor itself is pretty straightforward, consisting of a set of blocks such as turns, platforms, road pieces, that you can place on a 3D grid inside the stadium. The rules are simple. A track must have at least one start block and one or more finish blocks for the game to accept it as a valid track. While this does not seem like a complex task for any track builder, it gets interesting when we attempt to think about the possibilities of generating tracks fully automatically without human interaction. In this video, I'd like to walk you through the journey of creating an AI to generate brand new tracks in TrackMania. Starting out, we need to define what tracks we want to generate and what will be our set of steps to generate the final track. Building good tracks isn't quite an easy task, as the possibilities in-game are quite literally endless. In the most popular stadium environments, there are about 300 available unique blocks to build your tracks with. While building, track makers will often test their track in the middle of the process multiple times, evaluating speed, flow, and overall driving experience. A single track can consist of a lot of trial and error before it's pleasant to drive. This is why builders put a lot of effort perfecting their designs and even participating in map building competitions. Our end goal will be to generate tracks based on maps already built by the community in a certain map style. Over the course of history, TrackMania's map building community invented several distinct map styles that can be used to build a new track. Some of them include full speed, a style which features loops and wall rides that pushes you to always drive the car at full speed, dirt, which features mainly dirt roads and hills where the most focus spent is on the gear management of your car, and many more. I chose to generate tracks in the technical style, which is one of the most popular and developed style out of all, featuring tight turns and drifts around corners. All user-made tracks are uploaded on a map-sharing website called TrackMania Exchange, which will be useful to gather tracks for AI to learn. Its database contains more than 500,000 tracks at the moment, and is still very active. Because the website allows you to sort by map style, length, rating, and more, we can filter the tracks we are interested in and form a dataset of example tracks that we will feed into the AI. This technique is called supervised learning, which means we have an existing set of data points, in this case the tracks, that we want to train our neural network on. Because the tracks consist of singular building blocks, we will generate the track block by block, placing each block one after another. This will give us the most flexibility, as it allows us to manually delete blocks if we reach a dead end, and with this method, we can also decide when to place the final finish block. Building the track this way will require our AI to learn to place blocks in the correct order, and this is why the data we feed into the network must be in the correct order as well. To achieve this, we need to extract and process our data in a specific way from already existing tracks made by the community. For obtaining decent results, I've downloaded about 3,500 technical tracks of the length of about 1 minute from TrackMania Exchange. Each track is a file with a special GBX extension, which is the primary file format TrackMania uses to save your tracks, replays, and more. So, how does the game actually save your maps? A map consists of a list of blocks. And each block consists of the three main properties: name, position, and rotation. The name of the block simply identifies what kind of block it is: a platform, a roadblock, a booster, or something else. For example, the start block has the name of Stadium Road Main Start Line. And this platform block you see here, Stadium Circuit Base. The position of the block are the X, Y, and Z coordinates that represent its placement on the map. The final property, rotation, is a number representing which direction the block is facing. A rotation of 0 means that a block is facing north, 1 east, 2 south, and 3 west. Now, almost all of these properties are a number, except the name of the block. Neural networks work primarily on numbers, so we have to convert the remaining name into a number as well. We can do that by simply assigning each of these block names a unique number. So for example, the start block will be block number 1, finish block will be number 2, a road block 3, and so on. After this conversion, we now have converted the block into pure numbers that can be fed into the AI. Neural networks work by making guesses based on what they saw previously in the training process. A network takes some input we feed into it and spits out an output we can use to make educated predictions. By learning the relations between the input and the output, the network can accurately learn the task we defined, based on the samples we showed when training the AI. For generating our track, we will utilize two separate neural networks that perform their own task. Let's take a look at the block network first. The task of the block network is to predict, based on previous blocks we placed, what type of block to place next. Say that we initially placed the start block on the map. What we want to know is what block to place next. Because there are multiple possibilities in continuing from a single start block, our network will predict the probability of each block being placed in this scenario. Using these probabilities, we can randomly choose our next block to place on the map. In this case, suppose we chose the downhill block. We also want to know where to place it on the map and in what orientation. After all, we can place it in a variety of different configurations that don't even make sense. This is where the position network comes in. The task of the position network is to predict where a specific block should be placed. In this case, our position network will receive the first start block we placed and the downhill block we want to place as the input. At the end, the network predicts two things: the position of the downhill block and its rotation. The network has correctly predicted that the downhill block should be connected with the start block in this orientation. We place our newly generated block and we repeat the process. This time, we feed the 2 previous blocks into the block network. We collect the outputs and randomly choose the next block we want to place based on all the probabilities. We also do the same for the position network, feeding the 2 previous blocks and the next block we want to place. We repeat this ping-pong process between the 2 networks until we reach a track length we are happy with. At the end of the generation, we want to place a finish line, so we will simply skip asking the block network for the next block and ask the position network instead to tell us where the finish block should be placed. This is the entire process of generating a new track. Now, let the training begin. After training for 30 generations, our two neural networks are now able to accurately predict what types of blocks to place to build a technical track. The networks definitely learned to imitate the technical style to an extent, but driving them is not as pleasant as driving user-made tracks. Unlike human-made tracks, which sections are tested multiple times in-game by their creators, our system does not have this ability and cannot check how well the track flows before continuing building the track further. Despite this fact, I am very satisfied with the results and overall performance of this AI. It is not the most impressive application of machine learning you have seen, but it for sure allowed me to learn more about how neural networks work, and that was my goal when starting this project. Now, I did skip quite a lot to keep the content entertaining and the video itself not too long. If you are interested in more details, I wrote a post way back at the end of 2018 detailing some of these things I left out. You can also take a look at the project's GitHub page, where all the source code and scripts are publicly available. All of the things you have seen today were implemented years ago, and looking back, it was a great project to be working on, where I learned a ton of new things along the way. The generator was even once used in one of the editions of a weekly TrackMania competition called True Talents Cup. I was really excited when it had been announced, and I was of course there to play it when it happened. Sadly, the cup unfortunately isn't a thing today anymore, but I'm glad I could bring something new to the table for the players to enjoy. I've put all the links in the description, including some of the maps that were generated by the AI, should you want to check them out. If you like my work on TrackMania projects such as TM Interface and Competition Patch, you can consider donating through my PayPal page. Any amount is greatly appreciated, and it motivates me to work on those projects further. For now, that's all I have for you today, and I hope you enjoyed our journey through building a map generator for TrackMania. Thanks for watching.